Today we're going to do a quick review of triangle basics. Everything we talk about today you should have learned in the past, but I want to make sure we're all on the same page when it comes to learning the appropriate vocabulary we need for geometry. Okay, so the first thing we're going to talk about is classifying triangles. Triangles can either be classified by the lengths of their sides or the measure of their angles. If we're classifying triangles by their sides, we have three different types: equilateral, isosceles, and scalene, depending on the number of equal sides that they have. Okay, so here's our official definition. Okay, a figure is an isosceles triangle if and only if it has at least two sides of equal length. So if you notice, when you use the words at least, that means it could have exactly two sides, or it could possibly have three sides. If it's considered an equilateral triangle, then it has exactly three sides of equal length. So this is the same idea of rectangles and squares, where we all know that all squares are rectangles, but not all rectangles are squares. Well, all isosceles triangles are equilateral, but not all equilateral triangles are isosceles. Okay, the third way to classify a triangle by its sides is if it's a scalene triangle. And it's scalene if and only if it has no sides of equal length. And to show the relationship between figures, we can use what are called hierarchies. Okay, they work like a family tree. They show relationships and properties of figures. Next year, you'll be going into more detail with them. But this year, we're going to stick with triangles. Okay, our top of our hierarchy will be the most general figure, and we're going to work our way down to the most specific figure. Okay, so here's an example of a general hierarchy. Okay, the word figures at the top. A figure could be anything. It could be a smiley face, it could be a star, it could be a polygon, okay? It could be the letter V. Okay, we're going to break figures into two categories, though: circles and polygons. Okay, we're going to take a closer look at polygons, so we're going to go down the list. Well, maybe a polygon is an octagon. Maybe it's a quadrilateral. It could also be a triangle or a pentagon or any other polygon. We just picked these two. These are the two we were interested in. Okay. Well, if we have quadrilaterals, maybe the quadrilateral we're interested in is a rectangle. Again, maybe it was a trapezoid. Maybe it was a parallelogram. We're only interested in these specific shapes in our hierarchy. Okay, so if it's a rectangle, maybe it's a square. Square is the most specific figure. A square is a rectangle, a quadrilateral, a polygon, and a figure. Well, let's take a look at triangles. Okay, I want to take this group of figures, words, and put them into a hierarchy. So I'm going to look for the most general, and I'm going to work my way down to the most specific. Okay, so the top of my hierarchy will be figure again. Under figure, well, let's see, what's the most general thing after figure? We already checked that one off. Okay, polygons. All of these other things are polygons, so that's the most general. We keep going down, and then we have triangle. Okay, and then we can get into specific triangles. Okay, well, we have scalene triangles that have no equal sides, so that would go down under triangles. We also have isosceles triangles, which have two or more equal sides. Okay, So these two would be on the same level. And lastly, we have an equilateral triangle because it is a special type of isosceles. So if we were to draw this out, this is what we would have. Figure at the top, working our way down to polygon, working our way down to triangle, separating these two into isosceles and scalene. And isosceles triangles could be broken down into equilateral. We will practice more with this in class.